The world of samples, we now will explore infrastructures from the underground via the surface to the stars.
Thank you for the kind introduction. What I want to introduce to you are activities from the German Research Center in the context of setting up spatial infrastructures that have a certain importance for open science as well. Well, we all know that setting up research infrastructures is an urgent task, but rather expensive task as well. And at the same time, the activities of the public authorities, mainly in the context of spatial data infrastructures, to integrate their data. And this is a very important process because there are standards and for the exchange of data and the access to data have been established. And these concepts can be very valuable for the promotion of research infrastructures as well. I won't. But do I? Okay. That's not that easy. Okay. Okay. Possibly there's another button that can help me. Okay. What I want to introduce to you is one project. It's called Brandenburg 3D, Brandenburg in the federal state of Germany. And 2 years ago, we had about 2 million euros from European funding to set up a node for the spatial data infrastructure in Brandenburg that addressed especially the geological data. We have to know that in many cases in the geological survey, the data is not in a digital form, and that was part of the project. The other part of the project was to set up a node where the users could navigate and find data and also had access to the data. And what was very important for this infrastructure node, that the implementation built on open source software and that the visualization of geological structures should be realized in the browser. Okay, that is a picture of the architecture. I won't go into details. What we see in the bottom part, that we here have the operational part of the system, that is the store where the data is managed and organized, and we have an interface, a publisher, to the data that is visible in the internet. That at the same time serves as a service platform. We have standard interfaces, and the overall system is navigationable in the browser. Okay, that is the 2D interface to the system that we set up. That is nothing sensational. We see the drill holes, but what is more interesting, that is the subsurface structures that we can visualize as well, that we can use for the navigation in data. And that's really a huge benefit. And what does it mean for us? On one hand, it is now a platform that can be used for the implementation of data management platform, for example, for the Helmholtz Observatory in Chile. Additionally, we have new approaches for project data management, and we can offer tools for the geologists and the other people working with the data that are quite professional. And by the standardized approach, we are able to integrate this system into research infrastructures as well. And therefore, this system can provide a blueprint, an architectural blueprint for other systems, especially dealing with geological and drilling data management. And what is very important, that this system is open source and that it can be transferred to other geoscientific application fields. What is very important is that we now have a tool, a sophisticated tool to collect and provide valuable scientific data, that the software is open source and can be used, and that is one important step towards open science assembly for scientific geological data. Thank you.
Thanks. So next one is Chris.